Today we will be learning about gas stoichiometry at STP conditions. When we think about stoichiometry, we have to go back to the mole chart. The mole can relate to grams, particles, and finally liters. We can only relate the mole back to the liter at STP, that is standard temperature and pressure. For standard temperature, it is 0 degrees Celsius and it's equivalent in Kelvin 273. For pressure, 1 atm and 101.32 kPa. So I can put a 22.4, and that will only be true again at STP. Let's review the mole chart. I can find my grams value by looking on the periodic table, and that's called the molar mass. Particles, again, represents Avogadro's number, and that is 6.02 times 10 to the 23rd. What I have for A, I can now copy over to B. Finally, 22.4 liters of B. We can relate A to B through the molar ratio. This is where, in our conversion, we see moles over moles. Okay, we have our first problem. What volume of nitrogen dioxide gas is produced when 18 liters of nitrogen monoxide react with excess oxygen gas to form nitrogen dioxide at STP? We see that we are in STP, so I can relate 1 mole is equal to 22.4 liters. So anytime I see liters, I can plug 22.4 into it. Again, we do the same thing over and over. We need to check the equation to make sure it is balanced. I see just by looking at it that it is not, so I'm going to quickly balance it. Okay, so now we always look for the one given number, because in stoichiometry, we're always given one given number in the problem. So I underline the one given number, which is 18 liters of nitrogen monoxide. And I label right underneath it, 18 liters. We're looking for the volume of nitrogen dioxide, so liters. So what do I put in the first step? I put down the number that is given to us. I must have number, unit, and substance, always. And I always have to ask myself the first question when doing stoichiometry. Number 1, am I in moles? You're currently in liters. So in order to get out of liters, we need to cancel liters out by putting it on the bottom or copying and pasting. And if I'm not in moles, I put moles on top, so that now the next unit I am in is moles. Second question, am I in the right substance? Remember, stoichiometry is just relating one substance to another using molar ratio. So the answer is no, I want nitrogen dioxide, but I am in nitrogen monoxide, NO. So to cancel moles of NO out, I put it on the bottom, copy and paste, and write out moles of NO2. Last question I have to ask myself is, am I in the right unit? The answer is no, we want liters. That's volume, liters. So to cancel moles of NO2 out, I put it on the bottom and put liters on top. Now's the fun step. I get to plug in my numbers. So I have moles. Anytime moles is paired up with anything else, always 1. Anytime I see liters, since it's an STP, I put down 22.4. Anytime I see moles over moles, such as this, I need to look at the coefficient. I'm underlining where the coefficients will be so you can see. So for moles of NO2, I look at NO2 in my balance equation. So that would be this 2 over here. So I'm going to put that 2 right next to moles of NO2. For moles of NO, I take a look at NO, and I see that it's a 2. I'm going to put a 2 next to NO. So now I'm done with that. Now again, liters and moles. Anytime I see moles paired up with anything else except itself, it's always 1. I don't even hesitate. Same thing with liters. It's now 22.4. Now I multiply and divide, and I get, surprise, surprise, the same number. Notice 2 and 2 cancels out, 24.4 or 22.4 on top, 22.4 on bottom, that cancels out, so it's just the same number. So we have our next problem in the notes. It says, what volume of carbon dioxide forms from 126 grams of calcium carbonate at 1 atm and 0 degrees Celsius? Seeing this, I already know it is at standard temperature and pressure. And again, we can relate 1 mole is equal to 22.4 liters. That again means if I see L, I automatically put down 22.4. Underline the given number, box the unit you're converting to, have my equation, it is already balanced, label, so I have 126 grams, and I'm looking for liters of CO2. So I write down 126 grams of calcium carbonate. Again, the same questions, y'all. Number 1, am I in moles? Answer is no, so we need to be in moles. And what goes on bottom, again, copy and paste, don't even think about it. Next question, am I in the correct substance? I am currently in CaCO3, but I want CO2 from the question. So the answer is no, so I cancel it out. Copy and paste on bottom. Moles of CO2 on top. And now the final question. 3, am I in the correct unit? So the answer is no, we want liters, so I cancel out moles by putting on the bottom and put liters on top. Time for the fun part, plugging in the numbers. Moles and grams, moles is automatically 1. Grams, I need to go find the molar mass. So to find molar mass, I go to the periodic table and round those values to the hundredths. So I only have one of those. I have 1 carbon. The value is 12.01. I have 3 oxygens. 1 oxygen is 16, and it is times 3. That gets us 48. Add it all up. I get 100.09 grams per mole. So I put the 100.09 there. For moles over moles, all the coefficients, underlining it for you. When you don't see anything, we assume 1. So they're both 1. Moles and liters, so moles is paired with liters, so it's automatically 1. And liters gets that automatic number as well, 22.4. Our answer, once we multiply and divide, is 28.2 liters of CO2. So this problem can be found on the following page of your notebook. So after the gas stoichiometry notes, it says, assume that 8.5 liters of iodine gas are produced at STP. So seeing STP, I automatically know I can use the following relationship. 1 mole is equal to 22.4 liters. A balanced equation is given to us and a question. How many moles are produced? So we always underline the given number because that's the number we start with in order to convert. This is simply asking for moles of I2, and so it's a one step. 8.5 liters of iodine. No need for stoic or relating to another substance. It's all the same. So I simply put the unit I want on top, unit I don't want on bottom. Moles is always 1 when it's not moles over moles. And I have 22.4 liters. When I divide, I get 0.38 moles of iodine. That's the first part of the problem. Second part of the problem says, how many grams of potassium iodide were used? And so in order to do this, we need to use stoichiometry. So I'm going to start off with my given number again and convert, asking myself those questions. Am I in moles? I am not in moles, so moles it is, copy and paste on bottom. Next up, am I in my correct substance? No, I'm not. So I have to keep moles and change the substance to Ki. Copy and paste on bottom. And finally, am I in the right unit? It says grams. So now I am not, but I put grams on top, cancel the unit I had on bottom. So all my units are filled in. Now time to plug in the numbers. So I see moles for the first set, moles and liters. So moles is automatically 1, liters is the 22.4. I see moles over moles, so I need to go look at the coefficient. So again, I'm underlining the coefficient for Ki, or potassium iodide. I see 2, so I'm going to put a 2. For moles of I2, I see no number, so it's assumed 1. Next and last set. So I see moles of Ki. I automatically put down 1. And I see grams of Ki. I need to find the molar mass by going to the periodic table. So I'm going to do this calculation on the side. K is 39.10. And I only have 1 of it, so it's 39.10. I have iodine, which is 126.90. 1 of it again, so it's the same number. Add them up, and I get 166.00 grams per mole. So I'm going to put that 166 where I see grams, and I'm going to do my multiplication and divide by 22.4. And I'm rounding it to 2 sig figs, which is 130 grams of potassium iodide. And that is it.